This whole chapter is about like exponents and all these crazy rules, and I like it. It's lame, but I like it because it's just like at any job, if you have like a sequence of steps that you got to go through, like this will prep you for it. It's like I got to do this before I can do this, before I can do that kind of stuff. So it's a good thinking sequence. So I don't know how familiar you guys are with exponents and all that stuff, but are you cool? Like if I had x squared, which you can kind of see there in green, isn't that the same thing as like x times x? Isn't that what x squared means, right? And x cubed is really like x times x times x, like 3 times in a row. But do you notice that they are multiplying those two expressions together? So it's really like x times x times x times x times x. How many x's did I multiply together in a row? 5. So that can be cleaned up to be x to the 5th. And this is what's known as a product of powers. I honestly don't care if you know the name of that or not, you know, but it's been a while. Product means multiply, and aren't these just like powers? But the cool thing is they have the same base. Sorry, that's a bad highlighter used in that case, but are you cool that they both had like x's for the base, and like the exponents are the 2 and the 3 and stuff like that, right? So the shortcut is, if you're taking the same bases times each other, you just add those exponents up. Isn't 2 plus 3 5 in that case? So that's a little shortcut. And that would be really, really easy if it wasn't for this other thing, this power to a power. You see, x is still the base, but it's only there like once. Right? You know, like the other time we saw it there twice. Here, this is like x squared. Then they want to cube it. Well, doesn't cubing mean take it times itself 3 times in a row? So isn't that really like x squared times x squared times x squared, right? And now you add those together. What's 2 plus 2 plus 2, baby? That's 6. The shortcut is, what could I have done with those little exponents right there? I could have multiplied them together. And all this takes is practice. Right? So if we mess up a couple times, that is so normal. You know, let's do some practice right here. So check it out right here. This is really like y to the 1st. Are you with me on that? If they don't put an exponent there, it's really like y to the 1st. I could care less if you put that 1 there, if you know it's there. It's like you're a smart person. It's whatever works best for you. But isn't this like y to the 1st times y to the 5th? This is a product of powers. I would like to add those exponents together. So that would turn out to be y to the 6. Are we okay with that? That's all we're doing today, is just like simplifying some expressions. They want us to multiply some junk together. Cool. Right here, n squared times n to the 7th. Do you see how they have the same base of n? Like it doesn't have to be x. It could be whatever letter they want. So since it's n squared times n to the 7th, I should add those exponents together and get n to the 9th. Are we okay with that? And that's like the final answer and everything what you're typing into the computer today. So cool. And then here, like now we're going to start mixing it up. And here's basically the rule. We're going to take like numbers times numbers, x's times x's, y's times y's, z's times z's, n's times n's. Whatever letter that they're dealing with, we're just going to like go in phases. So do you see this term right here does have this stupid coefficient of -7 in front of it. He's a number, right? But aren't these guys right here x's, right? So we're going to just deal with the numbers first, then we're going to deal with the x's next, then we're going to deal with y's and the z's and whatever letters, just count one at a time. So -7 would actually be multiplied by this 1 over here. Isn't that still -7? Like we're just multiplying stuff together. And when we take x squared times x to the 4th, the weird thing is, yes, we are multiplying those together, but what do we do with the exponents? We add them up, right? And we get x to the 6th. So it's such a weird thing because, yeah, I multiplied the x's together, but I had to add the exponents to make the trick work. Is that kind of okay with you on that? So nice. And then I want to preview as it gets a little harder. Do you notice in the original problem there was not another exponent outside of those parentheses, right? So it will get a little more challenging. So let's do that with this. Notice there is not a little exponent outside the parentheses. Like if I skip down to like this dude here, do you see like how they have like a 5th power outside the parentheses? You know, that's what I'm kind of talking about. But they do not. So here's how we roll. Numbers times numbers. Help 2 times 8. What would that turn out to be? 16. Then a's times a's. A squared times a to the 1st would be a to the 3rd. Because there is like a 1 there. Are you with me on that? You know, so you're adding those guys up. And the other thing I've noticed is many students have a hard time saying those out loud. I'll correct you and help you. If you struggle saying it, we'll get better at it. So that's like 16a to the third power kind of thing. You know, a lot of people call it a cubed as well. It's the same thing, right? So, all right. Is there any numbers being raised outside the parentheses on number 5? Do you see anything like that? There's really a 1 there. Are we cool with that? But anything besides 1, so no. So let's roll with it. What order should you go in? Who cares? There's R's, there's N. It doesn't matter what order we're going to roll with. We're just going to go one letter at a time. So I'm going to rock with the R's. There's an R, there's an R. The other dude does not have an R, right? What's R to the first times R to the first? R to the second. Cool. And you kind of have to learn how to say it. I know it's still new, and we just came back from break, right? You know, so it's all that. Now let's deal with the N's. N to the first times N to the third times N to the second. Who cares if there's 3 of them? We just still add all the exponents together. It doesn't matter. So here's 1 plus 3 more plus 2 more. How many total N's are there, baby? N to the 6. Are we cool with that? Why don't you try the next dude with the neighbor? Deal with your coefficients first. I'll get you started on that. See, this has a coefficient of 1. The other one has a coefficient of 4. Always put the coefficients first. Then I personally go with X's, then Y's, like alphabetical order, because they're our most common guys, right? You know, but it really doesn't matter what order the letters are in, but you want the coefficients to come first, right? So give that a shot. Numbers times numbers, X's times X's, and Y's times Y's. And check it with mine, baby. 1 times 4 is 4. X squared times x to the first is x to the third. Are we cool with that? And then y to the first times y to the third is y to the fourth. Rock and roll. The most challenging part about this is typing it into the computer, and a typo means everything. You know, it's like watch your typos. So cool. All right. Here, this guy is different, though. Isn't this a power to another power, right? So we got to change gears. That is where we multiply the exponents together. So this should be y to the 10th. Are you with me on that? We got to multiply that, because it's like y to the 5th times y to the 5th is what they're really trying to get us to do right there in that case. So here, this would be n to the, what do I want to do there? Add or multiply? Multiply. It's cool if you got to punch this stuff in. It's the first day back, you know. So 7 times 4 is 28. Don't be afraid that you get really large exponents sometimes. It's going to happen, right? You know, so it's like, that seems weird, you know. It's cool. And then we'll rock that again. And now on number 9, this is the first real, I wouldn't call it a challenge, but the first step up. We always have to follow the order of operations. You remember, like, please excuse my dear Aunt Sally, or gemdas, you know, that kind of stuff. Would you believe that exponents come before multiplication in the order of operations? So I need to figure out this green nugget first. That's a power to a power. What should x squared to the 5th turn out to be, baby? X to the 10th. This little bit of work shown is what I'd like you to show as well. But would you believe that this x cubed has not been dealt with yet? So I'm going to bring him down. Are you with me on that? Like the first few, there was no work to show. You know, it's just a one quick hitter, you know. But here we had a couple steps. So now, what should I do with this? Should I get x to the 30th or x to the 13th back on this bad boy? This is an add the exponents together. And man, I've been around the block so many times. It is so normal if you like keep switching these rules around. That's why I love our online homework program, to tell you if you are right or wrong, you know. Fix it, you know. It's like everybody makes mistakes. Fix it. You know, it's like, oops, my bad. I should have added those together. Cool. So, all right. Let's talk ourselves through this guy. They want me to take this nug times this nug. Are any of those nugs raised to an exponent? Like outside the parentheses, is any of that happening? Yes, it is. You see, this whole guy right here is getting squared on the outside. So we've got to clean that up first. This will become b to the, tell your neighbor what you think. It's either the 5th or the 6th. You know, b to the 6th, because it's a power to a power. You multiply those guys. Then I need to just take all this stuff times it. 2a cubed b squared is going to come on down. And then we just start over. Numbers times numbers, a's times a's, b's times b's. Right? So here I had to do this first because of the order of operations. I had to do that exponent right there. I multiplied them, got b to the 6th. Right? Then I got to clean it up. So the 2 has nobody to play with. He comes along down for the ride. The a has nobody to play with, but the b's can play. B squared times b to the 6th would be b to the 8th. Is everything okay? We're doing all right? Cool. So now it's probably time to maybe like bust out a calculator on some of these, because check it out. Would you believe we've got some exponents on the outside, and the crazy little boys are these coefficients. The coefficients we got to just treat like normal, and if you would follow my lead, when you ever raise something to a power, you should put it in parentheses, right? If you put it in parentheses, your calculator will always give you the right answer back. So I want to take -4 and raise it to the 3rd. And that's going to give me -64. Because it's like -4 times -4 times -4, right? So it turned out to be -64. Then x, it's to the 1st right here. It needs to get cubed, so I'm going to multiply those together. Are you cool with that's going to be like x cubed in that spot right there? And then this y to the 1st, it's got to get cubed, so wouldn't that be y to the 3rd? That's that whole first little nugget. Would you and a neighbor maybe check out this nugget? You need to cube that dude. The coefficient is what you got to like punch into the calculator. Coefficient means number in front of the variables and all that stuff. That's that -2. So maybe you do know what they are in your head. That's awesome. You know, if you got to punch it in, that's awesome too. But it's -2 needs to get cubed. What is -2 cubed, my friends? Is it 8 or -8? -8. All right, -2 raised to the 3rd power. Boom. And then x squared cubed will be x to the 6th. Are we cool with that? Cool. Finish this off. Take numbers times numbers, x's times x's, y's times y's. Like I said, it's totally cool if we got to punch this stuff in. That's why calculators were invented, to make the calculations like -64 times -8 go a lot faster. So that's 512, right? And then the x's, even though we are multiplying the x's together, because the exponents are up there, we add those puppies up and get x to the 9th. And then the y has nobody to play with, so he's y cubed. Rock on? Cool. I'll kind of turn you loose, but I want to do it in phases. Can you guys figure this out together first, right? You see there's that little 2 on the outside. Got my j's taken care of, and then this -3 squared is actually going to turn out to be positive, right? So if you just realize that when you take a negative number times itself an even amount of times, the negative goes away. And then we got this times 8j to the 6th, k to the 3rd, right? And then you just multiply all those together. Numbers times numbers, j's times j's, k's times k's. This is why I like this, because you just have to do one thing at a time. You can't do it all at once, man. You got to just go in steps. So 72, j to the 10th, k to the 9th. You feel okay with those? Cool. Why don't you try, let me see what the last 3 are before I turn you loose on it. Yep. Why don't you try all 3 of those with the neighbor. Pause the video and then check back with me. The interesting thing is, if it ever says that you are supposed to put this in standard form on homework, they'll probably make you, they might make you rearrange that to put the b's before the x's. You know, like a lot of teachers like the letters to be in alphabetical order. I don't think it matters. If you're dealing with x's and y's, I just have like a personal preference that the x's should come first and the y's should come second, but it shouldn't matter. One thing that does matter though, like, is the 16 needs to come first. Like, we don't say x squared 16, you know what I mean? It's 16x squared. Are you with me on that? So, cool. That's the power to a power and the product of powers, and I think we can handle one more. It's called the quotient of powers, but every math textbook is going to tell you to do it to subtract the exponents from each other, which honestly is way harder than you think it is, right? It is extremely challenging. So I have created a different rule. It's called like the where are there more game. And when will you use it? when, I'm going to come back to number 1. I don't like number 1. We're going to come back to number 1. We're going to start with number 2. When will you use it? So when you got a fraction involved, right? Quotient means division. You see that they're like doing like some sort of division. There's a fraction. And here's what I like to call them. Get used to it because this whole chapter is based on it. You got 2 houses, upstairs and downstairs. Are you cool that upstairs is the numerator and downstairs is the denominator? You see how they have the same letters, right? M is the base. So aren't there like upstairs, M times M times M times M times M times M? Isn't there 6 of them being multiplied together upstairs, right? And downstairs, it's just M times M times M times M. There's only 4 of them, right? So the name of the game is called Where Are There More? Where are there more M's? Upstairs or downstairs? Upstairs. How many more? 2. So we will, like, kind of in theory, make a fraction, put the M's upstairs, and then would you believe there's nothing left downstairs, but there has to be something down there. And are you cool with the fact that it would be like the number 1? Honestly, you don't have to put it all over 1. I'm just showing you like you still have 2 houses, upstairs and downstairs. But just like the number 5, isn't it really like 5 over 1 if you was to write it as a fraction, right? So let's do number 3, then we'll come back to number 1. Number 3, they got p's and n's. We're just going to go one at a time, just like before. Let's start with a fraction bar. Boom. And let's roll with p's. There's 5 p's upstairs. There are 8 p's downstairs. Where are there more p's? Downstairs. How many more? 3. That's the name of the game, baby, is where are there more? So we'll do that with n's. There are 4 n's upstairs, and then there's that optical illusion of how many n's are actually downstairs. How many are really down there? There is 1 down there, right? They're trying to trick us a little bit right here. So the question is, where are there more n's? Upstairs, and how many more? 3. Are you cool with my game? I'll explain the real way next time. You won't like it, and you'll be like, can we please do this instead, right? But today we don't have time for that. Is that all right with you? So, cool. So let's go back to number 1. What makes it different? Why didn't I like it? I was like, I don't like this one. What's different about number 1 than 2 and 3? The base is actually a number, right? You know, but is it the same? It's 5 both times. So you can still play where are there more. We'll start a little fraction bar. Where are there more 5s? Upstairs or downstairs? Upstairs. How many more are there? 3, and it'd be over 1. The dumb thing is, homework probably won't accept that because you can simplify it. 5 cubed can be punched into a calculator, and I'll save you some time. It turns out to be 125, right? But if you just had m squared, like you can't clean that up any further. It is m squared, right? You know, but 5 cubed, this answer is 125 on that one. So when you have a number for a base, we gotta clean him up. So let's do that again. Where are there more a's? Why am I playing where are there more? Because there's a fraction. Are you with me? There's a fraction bar in this one. So where are there more a's? Upstairs or downstairs? Upstairs. How many more? 1. It's cool if you just type a. It's cool if you just write a over 1. It's also cool if you write a to the first over 1. You know, anything like a is fine, a to the first is fine, and a over 1 is fine. Cool. So let's do one more of those, baby. One at a time. Let's roll with x's. Where are there more x's? Downstairs. 2 more. Right? And where are there more y's? Upstairs. 1 more. Right? So awesome. Number 6 is just a little different. And it's the most optical illusion. Do you see it has coefficients? Right? A lot of people want to say, all right, so there's like 16 more downstairs because it's a -2 and it's a 14, you know? It's like, we don't do that with coefficients. This is a fraction. If you had an answer like this, and I'd say, hold on, bro, can you simplify that fraction? Does -2 over 14 reduce? What does that reduce to? So what we'll do is we'll start with a fraction bar. We'll reduce all coefficients, right? Isn't that -1/7? Are you with me on that? And then with the letters, we play where are there more, right? With the letters, we play where are there more. So would you believe there are 2 more upstairs? Are you okay with that? Yes, yes, yes. Here's an interesting question on a first day back. Is this the same answer as that? It actually is. The negative doesn't matter if it's upstairs or downstairs. Are you cool that the overall answer is negative, right? So if you end up dealing with some of these negatives. A lot of times, let's say this was a -1 on the bottom. You know, it's like, oh, I'd rather that not be down there. Why don't you just make the top negative, and then you don't have to put the bottom, right? So we'll get there when we get there. The main thing is we get a little basics today. Cool. Try 7. Ooh, maybe we won't try 7. Where are there more x's, upstairs or downstairs? Same amount. Interesting. Anybody know what 5 divided by 5 is? It's 1. 7 divided by 7, 1. What's x divided by x? They cancel each other out, right? They divide out to be 1. So when they're the same, peace out, Girl Scout to those. We done with the x's, right? They're gone. Y's, isn't there a different amount of y's? So where are there more y's? Upstairs, y squared over 1. I don't know if I have one on the practice worksheet or not, but I'm going to make one up. You don't have to write it down. You can just watch. What if it was like x squared over x to the 4th? What if it was that? Where are there more x's? Cool. So a lot of people will just put an answer like that, and I'll be like, hold on, bro. Something's got to be left upstairs. What's got to be left upstairs? Isn't there a 1 there? Are you cool with like each one of those has like coefficients of 1 in front of them, right? So if you only have stuff downstairs, you still have to have a numerator, and it would turn out to be 1. Cool? So, all right. Let me go back a second here, and we were on number 8, right? Here's what we'll do. I know order of operations says we need to like do this exponent, but would you believe that the first step in order of operations is there anything to do inside grouping symbols, aka parentheses, right? So what we will do first is we are going to just kind of copy that guy down and look inside parentheses and go, can I clean anything up? You see how there's some A's upstairs and some A's downstairs, right? We are going to clean it up first. So I'll put me a fraction bar inside, and I'll roll one at a time. Coefficients, there's just a 2, right? A's, okay, I can play the game with that, right? Where are there more A's? Upstairs. 1 more, right? And B's, I know there's only like B's upstairs, but they can't just disappear. Are you cool that they still got to be upstairs, right? And it just so happens, since I put a fraction bar, I'm going to go ahead and just put a dang 1 there instead, you know? But now that I've cleaned up what's inside, I can cube what's in there so much easier and not have a big mess in that case. So everything gets cubed, and watch out for him. He's the weird boy. He is not an exponent. He is a coefficient. 2 cubed. Talk to your neighbor. If you got to punch it in, that's great, you know. What is 2 cubed? Is it 5? Is it 6? Or is it 8? This will tell you. 2 cubed is how much? 8. A to the 1st to the 3rd is what I got to do next. What should I do with those exponents right there? Multiply them together. So a to the 3rd, and then b to the 1st cubed, b to the 3rd, and then over 1 cubed. 1 cubed is 1. I'm not going to put it, right? So, all right, I'm going to give you a chance. We got a lot of time compared to what I thought we were going to have. We get out at 10:50. So here's what I'll ask you to do. Do you see how this whole quantity is getting cubed? Clean up the inside. Clean up the inside. Compare it with your neighbor. So before I even do that, do you notice that I didn't run straight to cleaning up the inside? I actually put the parentheses with the cubed on it, because that gets forgotten about more often than you would think. It's like, okay, this whole thing has to get cubed, right? Then I'm going to go clean it up. How about 4/3? As a fraction, does 4 over 3 reduce at all? So he stays. He's still 4/3. I got some p's up. I got some p's down, right? So we'll play where are there more? Where are there more p's? Down. I think we're getting that, right? That makes sense, right? You know. And then I got some r's up. I got some r's down. How do we feel that there are 2 more r's upstairs? Are we cool with the cleanup process? Now that it's all cleaned up, everything inside here has to get cubed. The 4, the r squared, the 3, and the p cubed. So we're going to go one at a time. 4 cubed. You got to punch it in. Got to punch it in. Notice I didn't put it in parentheses. Sorry, I just know it's going to be okay. You should put the negative stuff in parentheses. You know what I mean? If you have a negative base, then you can put it in parentheses. So 4 cubed, 64. Are we okay with that being upstairs? Then r squared has to get cubed. This is where we got one of those rules from the front side. Should I add those bad boys, or should I multiply them when it's a power to a power multiplied? So that would be r to the 6. All right. 3 cubed, 27. And then p cubed, cubed. P to the 9th. Here's a cool little fact. If this didn't reduce, it's not going to reduce once you cube it or anything like that. So you shouldn't have to check. Is that okay with that? It's like that's why we do all the reducing first, right? Get all that stuff done. Nice. Let's see what we got left. How many? Is this the last set? These 3 right here? Cool. Let's go one at a time. Clean up the insides first. Clean up the insides. Pause the video. Come back and check with me. So there's number 10 and 11. Just watch your coefficients that you cleaned up everything inside first, then watch your coefficients if it turned out what we're supposed to. And then I'm going to roll with r's. There's 1 more r downstairs. N's, 4 more n's upstairs. And t's. What happens when there's the same amount? What do those do again? I'm cool that we say cancel out. I say it all the time too. They divide out to be 1 is really what ends up happening, right? So cancel each other out. Cool. All right. Let me know if you have any questions. Have a good one.